Okay, it's recording.
Go OpenWRT next month. Switch from PFSense.
Oh, I've made that change as well. Yeah. For a couple of years, my router at home was a Dell GX1, so it was a P3 550 with 128 meg RAM. It was not for any mono wall and then PFSense. And then I upgraded to stuff you'll see in the presentation. And I'm in the process of upgrading yet again. So,
PFSense, the next version of PFSense will support IPv6. And it
doesn't support it all right now?
Not at all right now.
Oh, I didn't even know that.
And your talk convinced me to run dual stack. I wanted to do it for some time. I do hosting just out of my home, and your talk this morning convinced me. I got to do IPv6.
It's pretty cool to have a V6 setup and be able to use it. And I mean, for me, the huge thing is like the world is routable again. The whole like NATs out the rear end that we currently have and impossible to reach anything without configuration is a giant nightmare. Yeah. And I mean, I wasn't there when AWS made these decisions, but something tells me that all of the network problems that my AWS has is all because they were on V4, or they didn't have the ability to do V6, and the world wasn't ready for V6. And so, I mean, just imagine how much nicer all the cloud stuff would be if there was V6 everywhere.
I still have a hard time getting my grip around how V6 works, though, like the addressing scheme.
It doesn't work any different.
I know, but it's because it looks different.
Yes. So there's this initial, like, you know, the leap of faith at the beginning. But once you do that, it's like, you know, the eyes are opened and the world is glorious again.
Yes.
So, anywho, I can put this one. Hopefully that. How's everyone doing?
Terrific.
Good. Which, by the way, too, good presentation on the PSC stuff. I'm going to have to give that.
And I plan on adding IPv6 support with it within the next month, because I'm going to do some further testing.
Okay.
So once I do that, if you use that and you test it, let me know if there's bugs or.
I don't know about the ifconfig commands, but something tells me it would just be
It's old school. It's old school ifconfig. It's easy.
Yeah. Okay.
Instead of inet, it's inet 6.
All right. Hopefully that thing is recording me, and hopefully I don't kill it. All right. So welcome to my presentation using OpenWRT to make your router take flight. A little disclaimer. It's not actually going to be flying. Sorry, that was just a name I threw out from the top of my head. And sorry that you couldn't make it to Cooking for Engineers.
I chose this one over that.
I actually kind of wanted to go to that one. So a little bit about me for those who weren't in the IPv6 one earlier. I'm a long-time tech geek. 13 years working with computers in a professional capacity. Several years as a Linux sysadmin, some Glitch and Mosey. Currently masquerading as a software engineer. Not really one, I just pretend to be one at work. I'm much more of a sysadmin. I mean, playing with stuff like this is what I do. I'm a tinker. And I graduated from BYU in Information Technology. So, brief outline of what I'll discuss. First, what is OpenWRT? Then we'll get into some of the basics of of what home routers really are. They're surprisingly powerful machines. I'll talk about how to build OpenWRT, which is an optional step, how to flash it, configure, and then extending it to do other things. So first off, what is OpenWRT? Well, it's an embedded Linux distribution. Everything in it is built from mainline source packages with a minimal set of patches that the OpenWRT devs maintain, and they try not to maintain them. They, if at all possible, will try to push things into the mainline source. This is a little different from some of the other third-party router firmwares that have been available over the years. Some of those, instead of compiling from the mainline source, they'll take the source provided by the manufacturer of the router and modify that. Or I believe there was even some really crazy places where they actually just took the firmware and modified that in place to add additional functionality. DDWRT used to be this way before V24 or V23. It would use the manufacturer source to build instead of the mainline source trees. So that was one difference. And then lots of other differences underneath the hoods. It's UC libc based and busybox based, so really small footprint. There is package management in it by default. You can actually remove the package management from the resulting firmware, so you just have a directory tree and don't have the ability to install packages on the resulting firmware. But by default, it does include it. Use opackage, which is the continuation of what was iPackage from the iPack Linux days, way back in the early 2000s. And it's meant to be an extensible router platform. It supports a wide variety of CPU architectures. These were the ones I was able to find by quickly browsing through the source tree. The vast majority of routers out there, the CPU architecture is actually MIPS, but they have all kinds of stuff. There's quite a few PowerPC, a few ARM. I was really surprised to see the AVR32 architecture in there. And then x86 is quite an intriguing one. They actually have a build target for KVM and Zenguess. So you can build to natively run inside of a virtual machine of those types. It supports a wide variety of routers and development boards. Here's a few that I've used or have interest in. The good old Linksys WRT54G/GL. This is where the project really started and has been a staple of this community for years, although it's starting to show its age and not used a whole lot anymore. I haven't heard of really anyone going out and buying one of these lightly due to the limited hardware in it. Its problem these days is it only has 4 megabytes of flash to store the firmware imaging, and just a base OpenWRT image when you add the web interface is like 3-something megabytes, and so you don't have much room to extend it. And so the community is starting to go to devices with faster CPUs and more flash. It only has a 200 megahertz CPU in it, and single band wireless G and whatnot. So, this is actually what I am currently running as my home router. It's PC Engine's ALIX. It's a fun little board. It's got a Geode 533 x86 processor on it. You have a choice of a number of actual Ethernet ports. These aren't connected to a switch chip internally, so you actually get full speed on them. Unfortunately, they're only 10/100. And then mini PCI slots and a couple of USBs, which gives you the ability to add all kinds of stuff to the device. And routers that have a USB port, I mean, the sky's the limit on these things. This is a really, really fun device. This is the WNDR 3700/37AV/3800. I should put a caveat. There is a version 3 of the 3700, which completely changed the internals of the device. So if you go looking for one, make sure you look on the box and that it doesn't say V3 in the package contents, because that one is not supported at all. But these other ones are. These have like 16 megabytes of flash, so compared to these old school things, it's a huge amount of storage space, and between 64 and 128 megabytes of RAM, so I mean, you can fit all kinds of stuff on these things. And I have, I guess it's just one of these that I'm running OpenWRT on, and doing fun stuff with it as well. This is one, the Ubiquiti Router Station Pro. It's very similar in architecture to the WNDR 3700. Uses the same CPU, same network interfaces. This doesn't include wireless, but it does include a SD card slot on it. Unfortunately, it's an end-of-life product, and Ubiquiti hasn't said what they're doing next, if they are. A little on the pricey side, both the WNDR 3700 and this one are going to cost somewhere in the 110 to 130 range. So they're a little on the pricey side, especially as like a first project where you're afraid you might break it. But they're very capable and wonderful devices. I don't have a slide for that, but for this one, but another one, what I have here and what I'll be demonstrating with is this thing from Buffalo Tech. It's a WZR HP AG300H. So if you manage to catch that conglomeration of letters or numbers, it's the same basic design as this one in the WNDR. It's a little cheaper. I think I paid $80 for this thing on Newegg, and it's got 32 megabytes of flash. So it's just like, I've got huge tracts of land to store stuff in. But whereas other things are far less. So it's a really capable platform that's also pretty cheap. So some of the basics on, I guess as general basics, almost all these have something in between a 200 and 800 megahertz processor. This Buffalo and the Router Station Pro, it's actually got a 680 megahertz MIPS. So I mean it's got some decent CPU speed to it as well. 16 megabytes or more of RAM. These Linksys only have 16, but the others all the way up to 128. The PC Engine's ALIX, it's got 256 on it, so plenty of RAM. Don't have to worry about that. 4 megabyte or more flash. If you are looking to go get something now, I would recommend looking on the OpenWRT table of hardware. Find something with more than 4 megabytes of flash, because you can't fit a whole lot in that anymore. One or more network interfaces, both wired and Wi-Fi. Usually the CPU's wired interface is connected to an Ethernet switch chip inside. Sometimes on the CPUs there's actually 2 Ethernet wired ports that still both go to the switch. They end up on different ports, and so they get used differently. And I have a diagram to show how the networking is wired internally in a minute. There's lots of low-level interfaces on these things: serial JTAG, GPIO, and I2C. On this Buffalo, the weekend I got it in the mail, I tore it apart that same weekend. And it's got 4 pinholes on the PCB for an RS-232. And I happen to have a set of headers from an Arduino project, and just those headers fit in perfectly. I could have just soldered those on and used a FTDI USB to serial to get to the serial console of this device. One bit of caution though on the serial is they're all 3.3 volt, and so if you try to hook up your regular RS-232 adapter or a serial port off computer, those are 12 volts, I believe. So if you just connect those up, you'll fry your interface. So make sure you get something with the right voltage. And a lot of them include additional components like a USB port or a mini PCI slot. This Belkin down here that I have to clarify with me today, I should have left it so I could open it. It's actually got a mini PCI slot that the wireless card is plugged into. So if I wanted to use it as just a wired router, I could take that card out, plug in another mini PCI card, say a serial ATA card or a old school modem or something else, and use it in here as well. And then of course USB really makes things fun. So yeah, on a lot of them there's only one wired network interface, and so the question is how do you get both your WAN port and your LAN interface on the same thing? And the way that a lot of the routers will do this is they'll use VLAN tagging on the switch chip that the interface is connected to. Pretty much all of these, if there's a switch chip inside the router, it supports native 802.1q VLANs. And the system startup will configure them in a way so that one of them is on a different VLAN, and that's what the WAN interface will be on. That also makes it intriguing because it's got VLANs and you can do all kinds of cool fancy things with these, with multiple subnets and multiple networks coming off of these. As an aside, one crazy stupid thing I did at one of my previous apartments, the VLAN 1 that it says for the internet, I actually also tagged that on another port, which ran all the way across the apartment to my room, which I then I had a switch there, and I had my server that was plugged into it, and it was it had a public IP address as well. I did it in a really insecure way, and there was broadcast traffic all across the network. So it was a bad idea, but it worked. So let's see. And so, way too much hardware to use for just a basic NAT router. Surely we can do more. I mean, these things, we sent people into space with less than this. So for getting started, first step is make sure your router is supported, or that you acquire a router that is. The table of hardware at this link, they try to keep somewhat up to date, but it frequently lies on some things. Really the best thing is start searching the OpenWRT forums for people who have worked with the device. If it does say that it is supported on the table of hardware, though, you're pretty much guaranteed that it will work. But there are some things on there where they say it's a work in progress or something else. But it does work, maybe in limited fashion. Yeah, or they have a whole section of stuff that's in progress. And so if you're kind of adventurous and are willing to hack to get to the serial interface, the devs would probably love you for taking the time to actually figure some of those things out. For getting a image to flash, you can get it from downloads.openwrt.org. This is the directory structure that they use. And actually, let me bring that up real quick if I have decent internet access. So they've had a couple releases. White Russian was, and this probably the wrong thing considering the general populace of the area here. Their code names are based off of alcoholic drinks. So the first one was White Russian. Their second release, which is also what they used to, well, they either used to or still call the latest trunk version, is Kamikaze. Backfire is the most recent release, and they have recently tagged one called Attitude Adjustment, but they don't have it here because it's still in development. So if we go to the backfire, these were all the individual releases. 10.3.1 is the latest official release. In here is the, it's based on board type. So for like all the cool device here and the ones I was mentioning, it's an Atheros 7100. And then here's all the images for the different types of routers that they support. So like here's all the 3700 and whatnot. And right down here is the Buffalo I have. So anyways. Again, refer back to the table of hardware because they might give one-offs there as well. If you don't want to get from there or you feel particularly ambitious, you can build your own firmware. Here's the basic steps. You're going to get a copy of the source. You can get it through SVN or Git. They have what they call feeds, which are additional, I guess you could call them repositories of software packages. What's available in just the base OpenWRT source tree is a really minimal set of packages. You then configure additional feeds. There's two main ones that I use. One that has just a menagerie of packages, another one that has the web front end. So if you want a web management interface, you grab that feed. You'll configure your feeds. You'll tell it to update them, which is, basically cloning the source tree for those. Then you have to install those packages, which really that install just makes them available in menu config. Here's two that you might want to use. Lucy is their web app. WOL, Wake on LAN. With that, you can set it up so that you could power on your home machines remotely if everything's configured right. And the last thing after you've set up your packages, you'll actually configure your build. And how many of you in here have compiled your own kernel, Linux kernel? Okay, so for you guys, it's going to look very, very familiar because it uses the same menu config system. Yes?
Quick question. Are you going to make these slides available so we can...
Yes. I will get the slides to the conference and they can, whatever they're planning on making them available. If you want to ask me afterwards, I can give you a copy as well. And in a minute, I'll actually be going through these steps. So you'll use make menu config to select what options you want for your firmware. And then you'll actually do the build. You just use make for it. I usually run it with time, so I know roughly how long it took because I'm frequently trying out new hardware boxes to see how fast this goes. I'll talk about parallelism when we actually get to the build. Once you start it, go grab dinner, go to sleep. It might take a while. My really beefy system at home takes about 30 minutes. If I do it on this piece of junk laptop I have, it takes like 2 hours. So, and it is going to depend quite a bit on how many packages you are including in the build. And then the resulting images in a directory tree. So, we're not doing too bad on time, so I will go ahead and show this in a demo. Here we go. So, this is a, okay, there we go. Dash B. Okay, so I pulled the Git version of the source tree into this directory, and I haven't made any changes to it. So, first thing we need to do is copy feeds.conf to just feeds, and then edit it. I guess here it show there's actually two web user interfaces that you can install. XWRT is one that was started and maintained by a group outside of the core OpenWRT developers. And it was the first one available. They've had it all going back to the early 2000s. Lucy is the newer one maintained by the OpenWRT devs. I prefer Lucy, and so I don't even bother with XWRT. And I am going to change this to use Git. Unfortunately, Lucy doesn't have a corresponding Git repo, so I've got to stick this view in there. Okay, now I need to update my feeds, and this is going to clone stuff. Hopefully it goes. Come on,
if it's already cloned, does it do an update next time?
Yes, it will. It won't redo the whole thing. For me, I did a git clean -dfx on the directory beforehand, so it removed all of them. Let's see. It should be pretty close to done. There we go. If I were to just run my make menu config now, none of the packages that are in any of these feeds would be available to actually build. You have to do this install, which just makes them available in the build system. So I can install Lucy, which it actually grabs a whole bunch of stuff because it has the ability to configure lots of different applications. Let's add with on there. Just for the heck of it. I like to add me some ZNC for an IRC bouncer. Now that those are done, we'll do make menu config. Let's try zooming out again. I don't know how good that is. Shooting it now. Oh, there we go. So, very similar if you've ever done a kernel build. The first thing you do is you'll select your target system type. The Broadcom VRCM 947, that's what the WRTs are going to be. A lot of your lower end single wireless band stuff is going to fit in here. I'm going to choose the Athros one because that's the thing we care about the most recently. You can select a sub-target type. For this particular one, there's not really many sub-targets. Let me go back to the VRCM. This one has a lot. For example, you could choose whether or not you're using the Broadcom proprietary wireless driver or the open source B43 driver. There are actually some systems that, even though they have a Broadcom CPU, they'll have an Athros wireless chipset, so they have support for those. And some specifics down here. Let's see. I guess these get into some specific boards if you have. There's the one that I have right here, so we'll select that. Target images, you're probably not going to worry about unless you're doing something, or doing like an x86 build, where you can, like, say for example, burn an ISO of your resulting image, so that then you can just drop that into a CD drive and run that as a live CD. There's one cool thing in the build configure, general or global build settings that I like to enable. And no, it's not this one, that's already picked. Here we go. Compile certain packages parallelized. By default, all the individual package makes that it's run, it will just run standard make on, so it's limited to one CPU core. If you check this, on some of them, if they support parallelizing the build, it will parallelize it for you. I usually leave it at just 2 myself on this. Unless you're really getting frisky, you won't have to worry about the advanced configuration options. The image builder and SDK are intriguing options. If I have time at the end, I'll talk about these. They're nice things that if you want to be able to modify your build later, they provide an easy way to modify it. The image configuration lets you change some of the base settings about what your firmware will end up with. By default, it's going to use the IP address of 192.168.1.1 when the system boots. But here you could change it so that it uses a different one, or maybe that it uses DHCP instead. For most people on their first tries, they're not going to change these. These are really going to be if you're trying to do crazy things with it. The rest of these down here are places to pick additional packages to go with the system. It's going to pick a lot of defaults based on your board type. For example, it's going to make sure that it's including the right kernel drivers for your hardware, stuff like that. But you can go through and add in additional things like this Lucy one. By selecting this, it will add in the web interface. On all of these, there's the option of the M or the star. If it's M or module, it will build the package, but the package won't be in the resulting firmware. You could install it later if you want. With the star, it's actually going to build it into the resulting firmware image, so it's there whenever you flash it. Me, I like me some IPv6. So there, I've made a few changes here. There's lots of things that you could go through. I like to browse through the network section whenever I do, or create one. One cool thing is it does have, there's OpenVPN, you can build in there as well. So we'll go ahead and now exit, and we'll save the configuration. Last thing is to actually run the build. This is a quote-unquote 8-core machine. Each package is being parallelized with 2 already, so I'm going to take the number of CPUs I have divided by 2, and I'm going to run with a parallelism of 4 here. And so the first thing it's going to do is it's going to go through and compile a cross-compilation toolchain. That's a pretty advanced topic that I definitely am not qualified to get into. But it's going to go through and compile a lot of things that it needs, and then actually compile the image. And this is going to take a while, so we're just going to leave it be for a bit. We're not going to be using anything that comes out of that, because I already have all that done for the rest of the presentation. So now is the hard part, is actually getting the image onto the router. Before trying, definitely check the table of hardware for information about your router. Some of them have oddities about what you need to do to get the image on there. Some do support flashing from the manufacturer's web interface on the router. The WRT54Gs do this and do it quite well. The Netgear that I mentioned earlier, it does it. Unfortunately, this Buffalo, I tried flashing through the web interface and it didn't take it. It rejected it. And so for it, I had to use another method where during the router startup, it actually will start a TFTP server, and wait for a connection for a few seconds. And during that time, you can send it a file, and it will write that file to the flash of the system. And it's a way to get around the web interface from the manufacturers. It's also really useful if you manage to make a bad firmware that say you locked yourself out of being able to SSH or telnet into the box, or you made it too big. I have flashed firmware images that were too big. That was not fun. This lets you get back out without having to break open the box or completely destroying your router. And this is a method that I'm actually going to be showing a little later, but it is still something you need to be a little careful with, but the chance of you actually destroying your router is pretty minimal. If you're really adventurous, you can actually bust open the box and flash through a JTAG interface or the bootloader itself. If you can connect to the serial port and talk directly to the bootloader during startup, a lot of times you can be able to load an image completely in RAM and run it without flashing it, so you can test out that way, or actually be able to write the image to flash yourself. But that's something I haven't tried myself, and I definitely do not recommend it for anyone who's trying this for the first time. And definitely voiding a warranty because you're opening the box. All right, so brief overview of how to flash using TFTP. You only have a few moments after the router has powered up. If you're using a Linux box and connected directly to the router, you're going to want to disable Network Manager for that wired interface. You can't flash over wireless, by the way. It's got to be wired. The reason being is that if you have Network Manager running, as soon as the router starts up, your box is going to detect link on the interface and immediately try to DHCP and start messing with things. And you do not want it doing that because you're going to want to use some manual settings. And while Network Manager is trying to figure out what to do, the router will have gone on and continued its boot process, so you missed the opportunity to flash. You're going to need to statically set the IP address to the same subnet as what the bootloader is using. A lot just use 192.168.1.0. This particular Buffalo we'll be doing is actually 11.0. You're going to send a TFTP to the bootloader address, usually 1.1. You're going to obviously you're going to need to use binary mode because you're talking about binary files. By setting the retransmit interval and then setting a long timeout, what you can do is you can start the TFTP client before you actually turn the router on, and the TFTP client will just keep trying to send, and that way you don't have to, have multiple hands in different locations at once trying to get it all going at once. So now for a demo, I guess. First thing, let me disconnect from this because that's a remote host, and I'm going to unplug. So first I'm going to plug into this guy so you guys can see that he's running a stock firmware. So, another intriguing thing about this device, see if on the firmware, it's actually running DDWRT by default. This one and several other wireless devices, they actually run OpenWRT or DDWRT as the stock firmware image, where they just rebranded the web interface. I got to give some props to the people who do that, because one, it's helping out the open source community to some extent, and you know, the things are ready for you to do whatever you want with them. So this is the default interface. The only thing I've done on this so far was set a password on it, but it doesn't require the password to do lots of things. So let's see here. I'm going to back over here. I need to pull up notes real quick. Okay, so first thing I'm going to do is, you can't see this, I just told Network Manager to disconnect my wired interface. So, here right now, yeah, I have no address on my ETH0 device. I'm going to go ahead and unplug the router. So we want that off. Now what I'm going to do first is bring up my network interface. And then I'm going to add the IP, or add an IP address in the corresponding subnet to it. Now this particular router is a little funny in that it is using a specific MAC address during this bootloader phase, and it doesn't respond to ARP. So you have to set the hardware address for it yourself before you do anything. So I'm going to go ahead and add that in there. So what I'm going to do now is run a TFTP client. I'm going to turn on a few things. So in my TFTP client, I told it, be verbose, turn on tracing. The timeout 60 says try for 1 minute to put the image, or put the file. The re-XMT1 means try every second until you succeed. And of course, binaries, it's binary mode instead of text mode. And this is the image that I'm going to tell it to flash. Note, there were several available. In theory, factory is what you would use on the web interface. SysUpgrade is what you'll use whenever you already have OpenWRT on the box. It's missing some additional headers that the factory firmware is going to check before flashing. And then the TFTP one, I believe, is what you use for TFTP. So anyways, we will now, let's see, let me change one thing real quick. Okay. So now I will go ahead and start this. It's trying to send the file, and I'm going to plug in the router. On this particular one, the red light means it's in the boot up phase, and I believe it starts flashing when it starts writing the firmware. So we'll find out if this actually takes here in a second. Oh, there we go. So there it wrote all the data to the router. It should be, yeah, the red light's flashing now, so that means it's writing to the device. And in a minute, it should restart and be running OpenWRT. And it's going to take it a minute or two. So this is a good stopping point for me to break and ask if there's any questions so far. Yes?
So, I have been interested in doing this on a D-Link that is supported, but the D-Link, like the way it's set up right now, does the dual band wireless N.
Mm-hmm.
Does OpenWRT support that, and how does that work?
So it will do the dual band. This one actually has both 2, 4, and 5 gigahertz, and both of them work.
Mm-hmm.
There is a slight caveat on the wireless N part of things. The open source drivers don't support much of the N functionality of wireless, and so you might lose some of the speed gains that the native manufacturer's firmware might have. But it will handle both the 5 gigahertz and the 2.4 gigahertz bands just fine. Yeah, I would recommend doing this. Well, one, I mean, if you're using wireless, you're not going for high speed anyway, in my opinion. But you will take a small hit on that performance by going to OpenWRT.
Can you build an IPv6 only build of OpenWRT?
So the question is IPv6 only on a build? I do not believe so. I don't know if you can even do an IPv6 only build of the Linux kernel right now.
Yeah.
So that would be one limitation. Yeah.
And do you know if you can build it on a non-Linux OS like FreeBSD?
So building on a non-Linux OS, I haven't tried. It might be possible. It does use the GNU toolchain for everything. So if you can get GCC and binutils and whatnot on your system working as it would on a Linux system, then I would guess it will. But that's something I have not tried and would be an interesting experiment.
So I run a build server and I build many different things, but it's on FreeBSD, so I'll give this a try.
Yeah. I would be very surprised if it built with a non-GNU toolchain.
Which
But
FreeBSD uses GNU.
oh, it does?
For-
Okay,
for
I
compiling.
didn't know if it had its own or not.
They're switching to C-Lang, but that's...
I would be surprised if it worked
Yeah.
with C-Lang. And because right now the kernel doesn't work with C-Lang.
Yeah.
So, yeah. Let's see, what's this thing? Oh, hey, red light went away, just the power light is on. Which, I guess let me go back to the next part of the presentation, which is about configuring OpenWRT. By default, SSH and wireless are disabled. There is no root password on it, and there is telnet running. So, your first step is to set a root password. You don't want to leave that wide open for everyone. Whenever you set the root password, it will disable the telnet daemon and enable an SSH one. And we'll get to this in a minute. Internally, OpenWRT uses its own configuration management system called UCI, or Unified Configuration Interface. It's a key value-based system with some extensions that allow it to do like lists and multiple layers of keys. You can interact with it both from the command line or from the web interface. The web interface is just a web UI that wraps UCI directly. If you use it from the command line, well, actually from the web interface as well, when you make changes, those changes aren't necessarily written to disk right away. They get staged, and then when you're good with the settings, you can commit them. This does give you a little bit of protection on making changes, because you can make changes, restart things, restart services, make sure you don't lock yourself out of the router, and then commit them. And if for some reason you do lock yourself out, you can just power cycle the router, and you'll get back to the state you were previously in. Lucy, we talked briefly about this. It's written in Lua. Yeah, I covered pretty much the rest of that. So let's take a look and see if things are my primary network interface through Network Manager. So I should grab a DHCP lease from the router now.
Do you need to clear that ARP entry beforehand?
It should clear in. Yeah, it got cleared by itself already, so. All right. I have a connection, so. So, again, it gave me something in 192.168.1, standard for lots of different routers. So if I tell it in, nice friendly reminder, set your root password. So I'm going to go ahead and do that. Be really secure and do a 5-letter password. And now in theory, I should disconnect and SSH to this as root. I guess I should fix 46. Oh, I don't need any of those. I can hear the security guy yelling back and forth. Just kidding. So now that we set the root password, we can SSH into the device. And if you've gotten used to configuring things from a command line, I definitely have, administering thousands of servers. You'll feel right at home here. Most of the configs for the system are stored in etcconfig in various different files. Let me show you the network one real quick. So this is what the network configuration file looks like by default. But configuring you can't just go in and edit these yourself. And I've done that a lot. That's actually the way I mainly do things, which is a really, really bad habit. The other thing you can do is there's a UCI command line tool. So I can do UCI show network, and here it gave me the key value pairs for the different things. Now we saw that wireless was disabled. Let's try enabling that. Let's see. Show. Oh wait. Okay. So here's the wireless configuration. There should be wireless.radio0.disabled and wireless.radio1.disabled. So let's do we'll set the wireless radio disabled to 0, and there should be also right here. There's a wireless section with a Wi-Fi I-face. You configure your different wireless networks separate from the wireless interface itself, because you can do multiple of them. You can, on a lot of chipsets, you can do up to 4 wireless networks on a single interface. Not something I would recommend playing with to start with, but something that you might find intriguing later or useful. I have done some crazy things there, but I don't recommend it. So we'll set wireless call this one -2.4 because this is the 2.4 gigahertz radio. Now I can do UCI changes and see the few items that I've changed. And I can do UCI commit, and it has actually written those to the config file now. Yeah, option disabled to 0, and the SSID right here is set to another 2.4. And after that, I need to restart networking to actually have the services see the change. And in theory, there now should be another light on the front. Yep. The LED for the 2.4 gigahertz radio is flashing. And if you have wireless devices on 2.4 range, hopefully you see an OpenWRT-2.4 network available now with no encryption. No big deal because it can't get anywhere. You do?
Yep.
Cool. So there's a little bit of a quick overview of the command line interface. Let's come back over here and go to the web interface to have a quick look around. So we'll put in our super secret password. So this is what the, oh yeah, this was built from the latest trunk of everything. Well, trunk as of a couple weeks ago. And so this is the latest version of the web UI. Let's go in and try to enable the second, or the 5 gigahertz wireless now. So if we go into network and Wi-Fi, we should see this one. It's not enabled, so we'll just hit enable. And this will actually go ahead and make a change, commit it, and restart networking. And we can now go into edit on this. Here's the configure. This is the interface configuration, so this is where you would set what channel you want to run. If you want to change the transmit power. Wow, they defaulted to the highest it does? Okay. So let's just change this to OpenWRT 5.0. Here you can see it. You can pick which network the wireless is attached to. By default, it's actually connected to a software bridge that is connected to the LAN interface as well. So anything that shows up on the wired ports on the back of the router will be on the wireless interface as well. But one of the simple advanced configurations, that sounds kind of oxymoronic. I'd say one of the first things you could try is splitting the wireless so it's on a different network than your wired ports. And so you can do all kinds of cool things there. Down here at the bottom, you can see there's a few buttons for reset with undo your changes. You just hit save. It will do the UCI set commands, but it won't actually commit them. And if you see up here, there's unsaved changes. Clicking this shows us what the changes are, and then we can hit either apply to just restart the services that are needed to, or that these settings affect, or save and apply. We'll commit them and then restart the services. So hopefully we should see another light. Come on in a second. Here's another wireless LAN light now. And if you have a device with a 5 gigahertz radio in it, you should see now a OpenWRT-5.0 wireless network. Unfortunately, my laptop doesn't have 5 gigahertz. So, oh, you do see it? Cool. That was quick.
I saw the standard, the default one too.
Yeah, that's what it was. Yeah. So there's lots of other things you can see in here. I believe I built this image with the end staff, and so you can see pretty graphs about what's been happening on your network interfaces. There's also some real-time graphs. These are kind of cool because they're dynamic SVGs. And so like this one is showing the load on the router in a few second intervals. And you can then also view, like the real-time traffic flowing across your network interfaces, etc. So there's some cool things in here. Let's see.
Can you add packages after the fact?
Yes, you can. So
centralized package repo?
There is on the downloads.openwrt.org for releases. They have every package that they had in that release built. And so if you flash an official release image, you can then come in here and go to software. You'll need to update the list because it it stores the list of what's available in the repo in RAM. But you can update this, and it will have a giant list of available packages. Mine's nothing right now. But they've got over 2,000 different software packages available. And so this is insane stuff. There's lots of other things in here. Unfortunately, we're short on time, so I can't go through a whole lot of them. But in services, you can then go in and configure different things, like say if you wanted to run a file server or a print server on here, you can configure a BitTorrent client in here, so if you have some persistent storage, you could, BitTorrent your favorite Ubuntu ISOs, or something that's legal. Open VPN configuration and network configuration. Lots of fun stuff in here that you can just go experiment with when you get to it. So there's a whole lot of cool things that you can do with OpenWRT. Here's a list of a few things that, I guess I haven't done all of these. I currently run an IRC bouncer on my router at home. I connect to a few IRC networks, and so it's kind of nice to have a persistent place to have a connection to those IRC networks without having a huge box wasting heat or paying a cloud service for a virtual server $20 a month. So that's really cool. The VPN endpoint's nice for connecting multiple locations. I've done this with OpenVPN between like my house and my parents. File print server, there's obvious use there. A voice PBX, there's Asterisk, OpenSCR, and I believe FreeSwitch available as packages. And so you can do some kind of cool things there. Though you might want to be careful to not overload the CPU. I would definitely recommend getting something with a fast CPU in it to do that. Simple web server, advanced routing. I have done this one. I've run Quagga on some OpenWRT instances running in VMs and did advanced routing that way. A very popular thing for OpenWRT is a mesh network. So you can have just a huge number of access points with only a few wired connections out to the internet and have this big wireless network. I had to throw in the taking flight somehow. There was a guy who hacked a setup with a WRT54G, an iPhone, and an RC remote helicopter. He was using DDWRT, not OpenWRT, but search for FlyPhone, and then whatever else you can imagine and build. I mean, the sky's the limit on these things, pretty much. All right, questions? And of course, my reference to the cookie.
What do you suggest for filtering? What's the best packages for that?
Filtering in what way? Content filtering?
Content filtering, yeah.
So they do have Dan's Guardian. I believe they have Dan's Guardian available.
There's OpenDNS.
Huh?
There's OpenDNS.
Yeah, you can configure it to use OpenDNS instead of your ISP's DNS servers. I haven't done much of that myself, so I can't really speak too much to those. But there are several packages available that you can do that with. There is Squid available, and so you can configure that yourself.
Isn't Dan's Guardian tied with Squid?
Yeah, it's Squid modified slightly, and with the content. There's an easy way to load content filters. If I remember right, there is a Lucy app to configure that stuff, but I haven't done it myself.
I would probably actually recommend PFSense over anything else because you could run a Captivate. I don't know.
So OpenWRT does support a captive portal,
Nice.
and the proxies do support transparent mode, so you can just use the firewall, the IP tables to force all outgoing 80 traffic onto the proxy.
What was the recommendation though?
PFSense?
Yeah.
I use that at home and it's been great. But I'm going to switch to OpenWRT soon.
PFSense is a FreeBSD based router platform. I don't think it supports anything but x86.
No, it runs on embedded devices, but they're like embedded devices you would see in the enterprise, not commodity hardware.
Okay, but it's based on FreeBSD and it uses the PF firewall, and they have their own based off of not a waltz thing, and they have a whole lot of similar features as what OpenWRT does, but slightly different target audience. Any other questions? Okay. Well, I do have. I'm not going to show these. I'll just briefly describe what they are. I mentioned the image builder and the SDK. The image builder, what it will do is it will bundle up all the packages that got made during the build process, and then put it in a tarball. You can extract that tarball later and rebuild the actual firmware images without rebuilding your entire system. And so if you build this and then say you erase your build tool chain or something like that, you can use this to rebuild the images with, say, a different set of packages. This was great for me because it was the only way I was able to fit the web user interface, OpenVPN, IPv6, libSSL, and a few miscellaneous things on a WRT54GL, which was an insane feat. I only had like 100K of storage space left after that was done. And I was making trade-off over whether or not to put something in the read-only firmware image, which goes on 64K boundaries, or leaving it out and installing it later because that might only use a few K. So that was a fun thing to play with there. That was instructions. The SDK is kind of like packaging up the build tool chain so that it can be used externally later. So you could then, if you're compiling additional packages later, you can just use this instead of having the full OpenWRT build system. It's great for third-party stuff, but for end users,